Okay, we're on section 1-3, solving quadratic equations. The definition you should put on your notes is an equation that, when in standard form, is in ax squared plus bx plus c equals 0 form. It's very important that you set it equal to 0, and we'll talk about that a little bit later on. Let's start by graphing it, and I'm going to graph a parent function. A parent function is the most basic type of function for any kind of graph, and the parent function for a quadratic is y equals x squared. And I'm going to show you all that one. You could also put it in your calculator if you want to go in and go to y equals and put in y equals x squared. And if you want to look at the graph, you can see it's a parabola. This is called a parabola. If you want to see the table of values, you can find that the vertex is at 0, 0. We're going to start by plotting that one. So 0, 0 is called the vertex. Let's go ahead and label that point. That's called the vertex. The other points are 1, 1, negative 1, 1, because 1 squared is 1. If you square 2, you get 4. And if you square a negative 2, you get positive 4. 3 would be 9. Negative 3 squared would be positive 9. So here's the parent function of a quadratic. The y-axis here is called the axis of symmetry. Let's go ahead and put that on here. And the equation of that line would be x equals 0. That would be your axis of symmetry. This vertex is called a minimum because it's a parabola facing up. You can have a vertex that's called the maximum. That would be if it was a vertex that faces down, and we'll talk about that in a minute. When a is negative, it'll turn upside down. Now this is kind of an important word, the solutions of a function. Let's write what that would be. That is where the graph of the quadratic function crosses the x-axis. And sometimes they have different names for these. Solutions can also be called x-intercepts, roots, or zeros. Let's underline those. Those are kind of the words they'll use. They'll either use the word find the solution, or it'll say, let me move that up. It'll say find the roots, or it might even say find the zeros of a function. And the zeros, or the roots of this function, would be 0, 0, because it crosses the x-axis at the vertex. Okay, sometimes they're going to ask you to solve quadratic equations by factoring. This first one is already factored for you. Do you see the two binomials, 2n minus 4 and 3n plus 5? It's called the zero product property. If you set anything that you're multiplying the two factors equal to 0, because when you multiply to get 0, you have to use one of your factors 0, you just set each one equal to 0. This first one, to solve for n, you would add 4 to both sides. So 2n would equal 4, and then to solve for n, you would divide by 2. Both sides of your equation. So 4 divided by 2 is 2. So that's one of your solutions to this quadratic. The other one over here, if you solve for n on this side, you need to subtract 5 on both sides. That leaves you with 3n equals negative 5. Then you would divide out the 3 to solve for your variable. That negative 5 divided by 3 is a decimal, so let's just leave it as a fraction, negative 5/3. Those are called the two solutions of your quadratic equation. Now the other example, the other part on this one, if you solve by factoring, you cannot factor this until you've set it equal to 0. Remember, the standard form is when you have, let me write it up here, ax squared plus bx plus c equals 0. So you will need to get it in that form. So if you notice, the 28 is on the right side of the equal sign, and we need a 0 to be on the right side. So on this one, if we were to take the 2x squared plus x, the left side of the equation, to bring the 28 to the opposite side, we would subtract it. Subtracting it on this side would leave you with a 0. Now you can factor it. When you're factoring a trinomial, you need to look at the first term and the last term, and we'll worry about the middle term in a minute. You do need to find the factors of each. You need to put them in two binomials. So let's talk about factoring for a minute. The only factors of 2 are 2 and 1. The only factor of, well, there's several factors for 28. You could use 4 and 7. So let's try if we used a 7 and a 4. If you multiplied 7 times 4 to make 28, to get the 1, the positive 1 here, do you see how you would get a 2 times 4 would be 8, and 7 times 1 would be 7? So that would give you a positive 1, but the 7 would need to be negative and the 4 would need to be positive. So that would give you the factors of 2x squared plus x minus 28. Now we're going to set each one equal to 0 and solve for x. The first one, you would add 7 to both sides and then divide the 2. This one would be 7 over 2. Let's leave it a fraction. 7 divided by 2. The next one, you would subtract 4 on both sides. So your x would equal a negative 4. These are your two answers, your two solutions to number 2.